Hi guys, welcome to Little Wicket Railway. I'm Rob, and in this video I'm starting a project that involves this Dapol Pug. So I picked this up in the Rails of Sheffield sale for about £17. Why so cheap? Well, firstly, it's quite an old tooling. These first came out in 1984, but it's also got quite a few things wrong with it. It's missing a buffer, it's got a chip in the cab roof, there's no rear coupling, but the big one is that it doesn't have a motor. So why did I buy it? Well, I want to turn it into this locomotive, number 11211. And 11211 was used by the Michell and Butler's Cape Hill Brewery in the late 1940s to work on their industrial rail network, which ran all over the brewery and connected to the Harborne branch line. And that's the branch line I'm quite fond of. I used to live near where it used to run, and it's the branch line that I hope to recreate on my layout. So it would be nice to have a version of 11221 that I could run up and down it. But I hear you saying, wouldn't it have just been easier to buy a complete functioning version of this model? Well, yes and no. So I believe Hornby now own the tooling for this model, and they do still make a version of it, but it doesn't come in LMS livery, and also it's ridiculously expensive given the age of the model at £85. I could have purchased that version and tried to change the livery, but even so, it still has two major issues. The first one is that the new model isn't DCC ready, and I want my version to run on a DCC layout. And the second one, and the big one for me, is that the motor takes up half of the cab area. And I think it looks pretty awful, and I just could never be happy with that. So here's my three-stage plan to upgrade this and turn it into 11221. Stage 1, I'm going to see whether I can fit a Coreless motor inside the boiler. I'm going to make it DCC fitted, and I'm going to see whether I've got room to fit a stay alive, and I might even try and get a flickering firebox in there. Stage 2, if I can get this working electrically and mechanically, then I'm going to fix the buffer, try to repair the chip in the cab roof, add the coupling, and 3D print some detail for the cab, because I'll have space to do that now because I'm going to relocate where the motor used to be. Stage 3 is where this transforms from 11217 into 11221. I've already got the decals from Fox Transfers, and I might even try my hand at weathering. I've never renumbered a loco, and I've never done any weathering, so this could all go horribly wrong. So that's the plan, let's get started, and the first thing I'm going to do is take this apart and see what I'm working with. Okay, so here's the model, and let's start by removing the cab, which is held in place by three little clips. And it just comes away like that, and I'm actually missing one of the clips on here, but the cab is quite spacious, and it'd be nice to have some detail in there. We've got the separately fitted handrails as well. Here we've still got the motor mount, you can see it there, and it's just held in place with a single screw. So this would have held the Type 7 motor that took up most of that cab space. And you can still see the wires coming through the base there, which would have connected up to it. So that just pulls away. And now we're left with plenty of space, which I'm hoping to fill with detail later. Inside you can see there is a huge weight, and this model actually weighs in at over 100 grams, and I think most of it comes from that block inside. So now we just need to figure out how to get that out, because that's the space that I'm going to fill with the motor. So let's start by removing some screws. Does this one hold the weight in? No, that weight's still not budging. This one I think holds the base keeper plate in, and there might be some screws under here, I think. So let's try and get this off. There we go. So this is what holds the axles in place. No metal bearings on this model, it's pretty basic. And there we've got a couple more screws I can see, so let's try taking those out. See whether we can get this weight to slide out. So there's that one. This is the gear that I'm going to try and connect the worm drive up to. The weight's still not budging. Oh, the wheels have dropped out. And there must be another screw. Here we go. Yep, and the body has come away from the chassis, and there's the weight has just dropped out into my hand. So pretty hefty weight, I think. Let's get this screw out. There we go. So this is the bare bones of what I'm working with. And it's going to take quite a bit of modification, I think. This is the motor that I want to use, so it will fit inside the boiler at an angle like that so that the worm drive connects to that white gear that you saw me spinning earlier. It's an 8mm coreless motor with a shaft at each end. It runs on 6 to 12 volts and it spins at 13,500 RPM. I picked this up from eBay and it was just under £4. I might have to remove one of the shafts, and I think I'm probably going to have to extend one of the shafts as well so that it reaches the gear. And I'm also going to have to design and 3D print a mount for it. And this is the worm drive that I'm hoping to use. I picked this up from AliExpress. These cost a couple of pounds. It's a 0.3M, which I believe stands for module copper worm gear. And it's got a 1mm bore which fits neatly onto the end of the motor. As I say, I picked these up from eBay and AliExpress, but I think Train-o-matic also have these in stock. They're slightly more expensive, and they've also got versions with extended shafts and even flywheels. So I think in future I might give them a go. But you get the idea that it's going to point downwards and connect to that gear there. So that's what it will look like. So just taking a look inside the boiler, you can see that it's actually quite a large space, and inside there alongside the motor I'm hoping to be able to fit a Stay Alive. This is the Train-o-matic smart power pack, and as you can see it's quite large, so I'm not sure whether there will be space for it in there, but we won't know until I produce the motor mount. And this is the decoder that I'm hoping to use. The PD05A-3 from Butler and Haas, which is extremely tiny, measuring in, I think it's 5mm by 8mm by 2.5 or something like that. And it can take a Stay Alive. It's got all the basic functions on there, so if I want to be able to fit a flickering firebox, then I can also do that. Having taken the model apart, it was time to design a motor mount that would fit in the space that used to be occupied by the weight. In SketchUp, I started by modelling the motor and working out roughly where the worm gear would need to be, and then building the motor mount around that. This was the first draft. You can see it's roughly the same shape as the boiler. There's a piece inside that the motor rests on that holds it at the correct angle, and a retaining piece at the front. After a few revisions, I ended up with this. It dips in on either side of the top, and that's so it avoids hitting the rail mounting points when it slides in. And I've taken a notch out at the back at the top, which allows the motor to be angled down more, which means that it takes up less space overall. The retaining clip isn't shown here, but it's now a separate part that clips in and holds the motor in place. This was all sent to the 3D printer, and after about 20 minutes, it was ready to be tested. This is the weight that we removed from the model originally, and here's the 3D print. And as you can see, they are very similar shape, so I'm optimistic that this is going to fit quite well. So let's try it sliding it in here. Get these wires out of the way. And this way round, notch at the back, in we go. And that's quite tight, probably a bit too tight really, so maybe some more modification needed there. But let's put the motor in. I've trimmed off one of the shafts, the shaft at the back, and that's how it sits. And if I get the retaining clip, there's the clip, and it just slides in to place against the end of the motor, and then that's how it should fit in. So there, with the shaft angled downwards. Looks like I need to go back to the 3D model and either make it a bit smaller or trim some bits off to get it to fit properly. But I have realised that I definitely need to remove some of this plastic in the middle where my screwdriver is now, just to take it back so that the shaft can access the white gear. So I set to work removing the plastic and creating the space needed for the shaft to pass through into the chassis. I tried using a craft knife and snippers, but it seemed like the rat's tail file was working the best, and it was the perfect width. So despite being a bit messy, I ended up using that for the majority of it. After removing the plastic from the floor of the boiler, I realised I also needed to do the same for the chassis piece. Here you can see where I've taken the plastic back into the boiler area so that the new motor shaft can access the top of that white gear. And before I tried fitting the mount again, I needed to make some adjustments to the design so that it slides in easier. So this is the new mount design, and it's got a slit all the way along the top now, which allows the sides to flex in slightly. This will hopefully allow it to slide into the boiler and flex inwards if the sides of the boiler are pushing on it. I also made a slight change to the retaining clip. By tapering the ends of the bit that plugs in, that should make it easier to insert into the mount, especially if the mount is being squeezed inwards a bit. I've also cut a notch to make sure it doesn't touch the shaft. So we're back with the model, and I've got my new 3D printed parts, and the clip now fits in very well, so I'm happy with that. And you'll see also putting the slit along the top gives it quite a bit of flex. The other thing I decided to do was print it at 98% size, so let's see whether it fits in. So it's gone in nice and smoothly, but let me just use the tweezers to push it all the way to the back, and yeah, so that's as far as it can go. I think that's a pretty good fit. The other big change to the motor is that I've trimmed off one of the shafts, added a couple of wires so we can test it, and extended the other shaft using these 2 bits of brass rod. And I didn't know how to cut these, and I learned a good technique. So if you want to cut it without crimping the ends, you take your craft knife, you roll it over where you want to cut, and then using your pliers, you pinch at the point you've scored, and it gives you a nice clean break. So that was a good tip to learn. So let's go and put the motor inside the mount now. So it just slides into there and drops down, and then I should be able to get the clip in place, and I might need to use my tweezers to do this. So if I put that in there, this is going to be fiddly, I can tell. Let's try again. Okay. Right. Let's give that a bit of a push. I've got one end in. I'm trying to be careful not to trap the wires as I put the clip in. There's space for the wires to go in across the top. I think I've got it. So now you can see that the worm drive is sticking down through. So let's put it back on the chassis. So we've got to poke these wires through the holes. The wires won't be staying in this location because I need to change the wiring positions, but we'll do that after we make sure that the thing actually works. So there we go, that's in place, and the worm gear has engaged with the white gear there. So let's just put the screw in to hold these two together in the right place. So that's in. And I think we might be ready to give this a bit of a test. So I was just about to put this on the rolling road when I realised that this front section isn't connected to the chassis very well. So I need to somehow fix that before I can go ahead. So I'm hoping to try and put one of those screws that I removed, the ones that went through all the way into the weight, back in to hold the two together. So if I can get this base keeper plate off, that is the screw that I think needs to go back in. So I'm going to need to use my hand drill to go through into the 3D mount that I've just made. So here's the drill I'm using, and I've just picked one that was slightly smaller than the screw, and let's make sure these two are lined up because I want to make sure that I drill through into the correct place on the mount. And I think that's gone through very easily. So we should now be able to, let's try putting the screw back in. Yes, that seems to be going in. Let's put the base keeper plate back on before I knock the wheels out. It's very easy to knock the pickups out of position as well on these. So once you put the base keeper plate in, you need to check that all the pickups are in the right place as well. So now let's get it on the rolling road and give it a test. So we're on the rolling road and I've got my cheap Hornby power supply connected. Let's turn it up. Please move. Yes, there we go. Okay. Let's slow it down. And, well, it's moving, so I'm pretty pleased about that. It does look like it might be cogging slightly. It's just snatching at that rotation, but I'm not sure whether that's the motor or whether that's the connecting rods. It's got a bit of a wobble as well, but I think that's the rolling road. But it's moving, so I'm pretty happy with that. Let's put it into the other direction. So it kicks in around 20% power. It does do a fairly good crawl. It is quite noisy, so I wonder whether some of that noise will go away once we add a bit of weight and put the cab and all the extra bits on. Let's turn it up. If I hold it, maybe that will help stabilise it a bit. So that's a little bit better. So yeah, overall I'm fairly pleased with that. And the next step is to sort all the electronics out. So add in the decoder, move those pickup wires, and try and add in the stay alive, I guess. I'll see whether I can sort that that cogging out. Maybe it just needs to be run in for a bit. But okay, time to get the soldering iron out and sort out these electronics. Sorting out all the wires took quite a long time and my soldering skills are still pretty pathetic, so I'll summarise what I'm doing at 5 times speed. The Train-o-matic power pack that I planned on using has 3 wires and the decoder only takes 2 wires, so I started by removing the unnecessary white wire from the stay alive and then trimming and tinning the red and black wires. When I solder really small parts like this, I like to use black tack to hold the components in place, and the finest tip on the soldering iron I have, my flux of choice is Topnick TK83 liquid flux, which really seems to help. I then connected the stay alive to the decoder, but as it would later turn out, this was all a waste of time because this type of smart stay alive isn't compatible with this decoder, so I would later end up removing it anyway. Then I needed to dismantle the models for the millionth time so that I could sort out the pickup wires and remove the motor. Starting with the wires, I pulled them out of their retaining holes and worked out where I could drill a couple of new holes for them to feed up close to the boiler area. I drilled those out at roughly the same size as the original holes and then fed the wires up through. Whilst I decided if I was happy with the placement of the new pickup wires, I decided to remove the yellow and white wires from the decoder because I don't plan on using them at the moment, and the fewer wires the better to keep things nice and tidy. Then I went back to the pickup wires and decided that I was happy with where they were coming through into the boiler, so I trimmed them down to a shorter length, then stripped and tinned the new ends. The wheels kept falling out, so I temporarily refitted the base keeper plate. Then I turned my attention to the motor, so I removed this from the mount and started by removing the 2 wires that I'd added to it for testing. It was at this point that I needed to decide if I wanted to put the decoder in the back behind the motor or if I wanted to keep the decoder at the front, as this would change how long all the wires needed to be. I decided it would probably make more sense if the decoder was accessible, so I kept it near the front. It really is tiny, so I think it will just slot down the side of where the stay alive is going to go. Then it was time to connect the red and black decoder wires to the pickup wires, and I covered the solder joint with small pieces of shrink wrap. It's always a bit stressful wielding a soldering iron this close to the actual model, but I'm pretty sure that I managed to avoid melting anything. I probably could have made these pickup connections a bit shorter, but leaving them longer gives me more options for positioning the decoder, and I can always shorten them later. Next up were the orange and grey wires that connect to the motor. These were trimmed so that they were long enough to travel the length of the boiler and then have some extra slack on them so I could position the decoder. With everything connected up, it was time to reassemble. First, the motor gets placed in with the wires carefully arranged so that they feed through over the top. Then the retaining clip went in to hold it all in place. Next up was the stay alive, which, as I soon discovered from reading the Doller and Haas documentation properly, didn't work with the decoder, so ended up being removed, but this at least proves that it does fit. Finally, in went the decoder with the excess wiring, and this was just tucked in next to the stay alive, and it was time to give it all a test. So here we are, let's turn it up, and you can see that it is all working. It actually runs a lot smoother on DCC and it sounds quieter, and I'm not quite sure why that is. Maybe the Coreless motor didn't like the Hornby power supply, or maybe I've just managed to position the motor better this time, but I'm pleased with the way it's running. It does wobble around quite a bit, and that's because it's so light. It's much smoother if you stick a couple of extra weights on it. Here we go. And that's no surprise really. The original model produced by Dapol was over 100 grams and my modified model without any extra weight is only 35 grams. So one of the steps in the next video will be to try and at least double that. And I've got some liquid gravity on the way that I can use to try and increase the weight in various different places. And you may have noticed that the Stay Alive has been removed. That's because it turns out it wasn't compatible with the Dollar and House decoder, so I've taken it out and I should have a compatible Stay Alive arriving soon, and I'll add that in the next video as well. But I've got the new mechanism working well on DCC, so I think that's a good place to end this video. In the next video, I'll work on improving the performance and repairing the areas that are damaged. If you enjoyed this video, then please give it a like and subscribe to the channel. Massive thanks to my members and patrons for supporting the channel. I really do appreciate it. That's it for this video. Thanks for watching. I'll hopefully see you again soon.